Okay, today we are going to be looking at inequalities and how to solve them. We're going to review some of the stuff that you would have did in Math B30 in particular with quadratic functions, and you're going to have some deja vu moments. Before we get to that, though, we're going to look at some properties of inequalities. And instead of going through the general properties, which you can easily find in your textbook on page 26, which talks about, if A is less than B, etc., we're going to use some specific examples to illustrate it. So let's take a look at example 1. We're supposed to solve this. So we're going to solve for x. So we would just gather our like terms together. So 5x minus 6x minus x, and then plus 12. Just multiplying the number into the bracket. And we're going to isolate x. So I'm going to move the 2x to this side and subtract 12 from this side, and I get minus 18. Now, one of the rules of inequalities is when we multiply or divide by a negative number, we must switch the inequality. And if you're curious to why that is, just ask me sometime. I can show you really quick. Now the question also says specify using set and interval notation. So the solution set is a set of all numbers x such that x belongs to the interval that's less than 6, so from negative infinity to 6, but it's also equal to, because that sign is equal to. So we're looking at a closed interval. So that's one example. Let's take a look at another one here. What happens when we have an inequality with 3 terms? What can we do there? Well, same rule applies that whatever we do to one side of it, we must do to the other. So we're going to subtract 4 from all 3 sides. So let's go ahead and subtract 4. Subtract 4 from 8. Subtract 4 from 12. Is it still possible that a number could be less than 8 and greater than minus 12? Yeah, that makes sense. So let's divide by 2 now. Whoops. That should be an x. And that's possible as well, again using interval and set notation. That's between minus 6 and 4, closed interval. Now if this was a minus 2 right here, that would completely change this question. If this was a minus 2, then we would have a plus 6 here, and we'd have a minus 4 here. Is it possible for a number to be both greater than 6 and less than or equal to minus 4? No, that's not possible. So that same rule would have applied here. We would have had to switch that inequality if we divide by a negative. So we would have this and then that, and we would switch everything to being something that's possible or is true. And that really relates well to this last example, number 3, because there's a problem here. X is on the bottom, so what are we going to do? Well, we're going to flip each one of these inequalities. So let's go ahead and flip this minus 6 to becoming minus 1/6. And then I'm going to switch this to being x minus 2 over 2. And then I'm going to switch this to being minus 1 over 1, which is still the same. So the question is, what would the signs be? And if you think about which of these two is larger, well, minus 1/6 is greater than minus 1 because minus 1 is the larger negative. So when we talk about what would make sense, well, this value is going to be greater than minus 1, but less than minus 6. It's between minus 1 and minus 1/6. So the basic rule is if you flip them and they're both the same sign, that's one of the restrictions you'll see in the properties, is that these two have to both be negative or both be positive, or this rule doesn't apply. And then it's just the same as you would have done in question 2, multiply everything by 2. Add 2, so that's adding 6/3. So that would become 5/3. That would be now 0. And then we get our answer, and we could write that using interval and set notation. That's it. Let's get to work.